Topic 6. Charge interactions. History of electricity from Greeks to superconductivity. In the year 624 before Christ, a philosopher called Thales of Miletus discovered a yellow tree called electron. Thanks to the Greek word from amber and its relation to electrostatic, the electron got his name. Concept of electric charge and its interactions. Modern atomic theory points out that there are materials with an extra number of electrons, while others have a lack of electrons. These are called valence electrons. These are the last energy of an atom. The number of electrons in the outermost energy level of atoms of a material is determined identifying if it's charged, conduction or not. Coulomb's law and continuous distributions. Short Coulomb designed a torsion balance experiment where the electric force causes torsion in thread that is suspended from its upper end. The angle by torsion of the thread is used to calculate the magnitude of electric forces. The result helped him to create the Coulomb's law. The Coulomb's law establishes the electrical force between two charged objects is directly proportional to the product of the quantity of charge on the objects and inversely proportional to the square of distance between two objects. There we have the formula of the Coulomb's law, where F is the force of attraction or repulsion between charges, R is distance between charges, Q1 is charge 1, Q2 charge 2. Problem topic 6. A point charge Q1 equals to 3 times 10 elevated to minus 6, 12 centimeters distant from a second point charge of Q2 equals to 1.5 times 10 elevated to minus 6. Calculate the force that Q1 exerts on Q2. Well, there you have the formula and the results.
Topic 7. Electric field. The concept of electric field is if a body contains a specific amount of positive or negative charge, it generates an electric field around it, and it produces an attractive or repulsive force to the bodies nearby, so that the charged body interacts indirectly with the others objects through the electric field. Here's how can we determine the direction of an electric field. If the force over a test charge that is positive is of attraction, then the force points into the direction of the electric field. When the force over a test charge is negative, then the force points into the opposite direction of the electric field. Electric field lines. The positive charges lines will go outwards and the negatives ones will go inwards. A point of charge Q produces an electric field in every point in space. The intensity of an electric field is related to the density of field lines. The more field lines are in a point, the more intense is the field. Scalar form of the electric field. E means electric field magnitude, F means electric force between two charges, Q means the test charge. Here's the formula to calculate the electric field of a charge. E equals electric field magnitude, K means proportionally constant, that it's always a constant, Q means a charge, and R the distance from Q to any point in space. Here's the vector form of the electric field. When you substitute the Coulomb's law in the previous formula, you obtain the next formula. Electric field superposition principle. The electric field superposition principle states that the electric field of any charge combination is the vector sum of the fields produced by individual charges. To calculate the electric field produced by a continuous charge, divide the distribution in smaller amounts and calculate the field vector produced by each one. Perform the vector addition of all the components. Here's the problem for topic 7. Calculate the electric field strength 20 centimeters from a 4 positive charge. We have the data, and we just do the substitution, and the answer is 900 n divided by c.
Topic 8. Gauss law. This law is used to calculate electric fields and is an alternative to Coulomb's law. The reason why this law is used as an alternative is that it can calculate bigger fields, while Coulomb's law only calculates point charge. This law states the total electric flux through any closed surface is equal to the total electric charge enclosed by the surface divided by. This formula states what is mentioned above. These are all the correct formulas to calculate charge distribution used as a Gaussian surface. The problem we choose is the next. The square surface shown in the given figure measures 3 mm on each side. It is immersed in a uniform electric field with magnitude E equals 2000 nC. The field lines make an angle of 30 degrees with a normal to the surface, as shown. Take that normal to be directioned outward, as though the surface is one face of a box. Calculate the electric flux through the surface. The data is given to us is E equals 2000 nC, A equals 3 millimeters or 0.003 meters, and 30 degrees of angle. The formula we are going to use is the next. The substitution and answer are shown in the video.
Topic 9. Electric potential energy. Electric potential energy is formed during an event in which an object moves, leaving it in a potential state to move and generate energy. This is calculated with height, mass, and gravitational acceleration. This formula is used to find potential energy. You need to multiply a test charge by the magnitude by the distances of the plates. And to find the electric potential energy, you can use these two formulas. Then, thanks to these formulas, you can find the electric potential energy of a group of point charges. To calculate how much electric potential energy one coulomb will have, if placed in a specific place, you can use this formula. Problem topic 9. A charge of Q 2.3 times 10 times 19 moves in a straight line from a point A to point B at a distance of 0.8 meters. If an electric field applies work of 1.5 times negative 12 joules over the proton, find the electric potential of the charge at point B. So we have the data, and we use that formula, and the answer is 6,251 times 10 times 3. Topic 10. Electric potential. This can be calculated for point charges and systems of point charges with the formula below. K stands for the constant that is equal to 9 times 10 with an exponent of 9. And to find the electric potential for a system of point charges, the formula below is used, in which you need to add all charges in the system and divide. To calculate energy conservation with electric force, the next formula is used. You need to add initial potential and kinetic energy plus work, which equals to the sum of final kinetic and potential energy. To calculate displacement of a particle from point A to point B, the formula that is used is this one. Problem topic 10. At which distance from a charge of Q positive 12 should you place a charge of negative 3 mu so that the potential energy is 5 times 10 with a negative exponent of 3? We use the following formula, and the answer is distance equals, the distance is 0.0648 meters.